Hi guys, my name's Raz and today we'll be looking at Pythagoras' theorem. So firstly, what is Pythagoras' theorem? It's specifically for right-angled triangles, and what some Greek dude named Pythagoras noticed years and years ago was, if you have a right-angled triangle, if you draw a square by its longest length and a square by the two other lengths, the two areas, the green area and the orange area, will add up to the yellow area. So if we call this length A, then that area must be A times A, which is A squared. We call this length B, then this area must be B times B, called B squared. We call this C, C times C will be C squared. Yeah, the reason those lengths are the same are, like I said, it's a square. All the shapes are squares. So all the lengths of those sides must be the same. And that's equal to that. Hence, A squared equals B squared plus C squared. So this is only for right-angled triangles, not any other triangle. So how can we use this? Yeah, to our advantage? Well, here's two examples. First, we have an example where we're trying to find the longer side of the triangle, i.e. the hypotenuse. So if you didn't already know, the diagonal of a right-angled triangle is called the hypotenuse. Not to be mistaken with the word hippopotamus, it's the hypotenuse. So let's do it. So we know A squared equals B squared plus C squared. So our diagonal is x squared, and that must be equal to 3 squared plus 4 squared. Now, here's the genius part of it. We need to square root that. So we have the square root of 9 plus 16, which is the square root of 25, and so we get x is 5. Yeah, so this is a 3, 4, 5 triangle known as a Pythagorean triple. I might go into that in another video, but not now. So the hypotenuse of that was 5. We look at example 2. This time we are given the hypotenuse. So we have A squared equals B squared plus C squared, but this time we know what the longest length is. We don't know one of the shorter sides. So what's the opposite of adding 5 squared? You gal it, we minus it. I was going to write minus 25, which is also correct, but I'm going to put minus 5 squared. So what we end up with is x squared is 13 squared, take away 5 squared. So now we need to square root. And if you put that in your calculator, you will end up with 12. So that's Pythagoras' theorem, an introduction to it anyway. I hope you enjoyed the video. I'll see you soon.